All right, let's talk about artificial intelligence. We're going to dive into its surprisingly long and, frankly, pretty bizarre history. It's a story that doesn't start with microchips, but with a clever magic trick. And to really get what's happening now, we have to go all the way back to the beginning.
So first things first, let's just ask the basic question, because let's be honest, AI is a super confusing term. It's kind of this giant umbrella that covers a whole bunch of different and sometimes clashing ideas.
You hear this term thrown around all the time, and it gets stuck onto everything. We hear AI, and we might picture a helpful assistant like Siri, or maybe a terrifying robot like the Terminator, or even those invisible algorithms that decide our credit scores. All these things just get mushed together, and it makes it really tough to know what we're actually talking about.
So, to really understand the AI we have today, we need to hit rewind. We got to go back to the very start, to a time when the whole idea of a machine that could actually think was nothing more than a wild dream.
And our fascination with this idea, it's literally centuries old. You could say it all started way back in 1770 with something called the Mechanical Turk, a chess-playing machine that wowed everybody. It even beat Napoleon and Ben Franklin. Of course, it turned out to be a brilliant hoax with a chess master hiding inside. But it proved how badly we wanted to believe it was real. It wasn't until 1950 that we got our first real taste of machine learning with Claude Shannon's thesis, a little mechanical mouse that could actually learn its way through a maze. That same year, the legendary Alan Turing proposed his imitation game, which gave the whole field a theoretical foundation. And then, just 6 years later, the name artificial intelligence was officially born.
But the road from that early excitement was not a smooth one, not at all. The field went through these big boom and bust cycles. Researchers would get all excited, promise the world, and then just hit a wall. Progress would grind to a halt, people would get disillusioned, and all the money would disappear. These periods were famously known as AI winters.
All right, let's fast forward to the most recent AI boom, which really kicked into high gear in the 2010s, and this brought a totally different kind of intelligence to the table, one that was less about thinking like a human and more about predicting the future.
This whole era was dominated by one technique, supervised learning. The key phrase here is labeled data. You see, to teach an AI to recognize a cat, you had to show it millions of pictures that humans had already labeled cat. The machine basically learns by studying the answer key that you give it.
And this predictive AI became incredibly powerful, but it was mostly working its magic behind the scenes. This was the engine that was optimizing shipping for companies like Amazon, forecasting how many hotel rooms would be needed based on the weather, and powering the voice recognition on your smartphone. It's also what was deciding what video or article to show you next online.
So here's the crucial takeaway from that time. While this stuff was super useful for business, it wasn't really intelligent in the way you and I are. These systems were amazing at spotting patterns and making predictions, but they couldn't create. They couldn't come up with a new, interesting idea from scratch.
And then, everything changed. In 2017, a single research paper with a deceptively simple title was published, and it completely altered the future of AI.
This was it, the paper that changed the game. It came from researchers at Google, and it introduced a new kind of model called the transformer. And this wasn't just a small step forward. It was the fundamental key that finally unlocked how a machine could really understand the complex, messy world of human language.
So what did this transformer thing actually do? Well, just look at the difference. Before, AI that tried to write text was a mess. It would spit out grammatically broken nonsense like talking about how algorithms silently orchestrating every item. The transformer introduced something called an attention mechanism. It basically allowed the AI to weigh the importance of different words in a sentence to get the real meaning. Kind of like how you focus on keywords in a conversation. It could finally understand context. It went from gibberish to making sense.
And that massive breakthrough is what gave us what we now know as large language models, or LLMs. And what they do, at their very core, is actually surprisingly simple. They just predict the next most likely token, which is just a word or a piece of a word. Really, you can think of an LLM as autocomplete on steroids.
So how in the world do you teach a machine to do that? I mean, it's an unbelievably complex process, but the best way to get your head around it is with a little analogy. Okay, so imagine an apprentice chef. The first step, they study a massive library of recipes. That's the AI's training, where it basically inhales all the text on the internet, in books, everywhere. Then they practice. They try to remake the dishes over and over, comparing their results and making tiny adjustments.
As they do this, they start to figure out their spice rack, learning through endless trial and error which flavors go together. This is like the AI fine-tuning billions of tiny connections, or weights, between all the words it knows. And finally, after countless hours of practice, that apprentice becomes a master chef who can create brand new, amazing dishes on their own.
So as researchers started building bigger and bigger models, feeding them more and more data, something really weird and totally unexpected started to happen. These AIs began to show off skills that no one had ever programmed into them.
Let's just look at an early model from 2021, GPT-3. If you asked it to write a limerick, this is what you got. It's terrible, right? It doesn't rhyme, it has no rhythm, there's no joke. It's a machine trying to imitate creativity and just falling completely flat.
But then, fast forward just 1 year later to GPT 3.5, this was the model behind the first ChatGPT, and suddenly it's a completely different story. This limerick is actually pretty decent. It has the right structure, it rhymes. I mean, the leap in ability in such a short time is just wild.
And this perfectly illustrates the next massive jump. GPT-4, which came out in 2023, gives you a limerick that isn't just technically correct, it's actually clever. It's witty. The jump from just clumsy imitation to genuine creativity is, well, it's astounding.
And this crazy improvement wasn't just happening in poetry. The real shocker came from standardized tests. On the uniform bar exam, the really hard test for lawyers, GPT 3.5 scored in the 10th percentile, a total fail. GPT-4 scored in the 90th percentile. In 1 year, it went from failing the bar exam to passing it as one of the top students.
But here is where it gets truly bizarre. Let's look at this paradox. You can give GPT-4 a super complex task, like write all the code for a perfect tic-tac-toe game on a web page. And it does it, flawlessly. But then you give it a dead simple task. Here's a game of tic-tac-toe in progress. What's the best next move for O? And it fails. It suggests an illegal move. It can do the incredibly hard thing, but not the trivially easy one.
This is a phenomenon that scientists are calling emergence. These are complex skills, like acing the bar exam or being genuinely witty, that just seem to appear out of nowhere in these huge models. Nobody programmed them to do these things. They just emerged. And the honest truth, no one is 100% sure why a system that was only designed to predict the next word can do any of this.
And that brings us to today. We set out to build a machine that could think. And after a long and strange journey, we've ended up with something else. Something that has learned how to reason and create, but in a way that isn't really human. Its strengths are baffling, and its weaknesses are bizarre. We have essentially created an alien mind. Which leaves us with maybe the most important question of our time. How do we make sure it's a friendly one?